the pressure, volume, and temperature of any fixed mass of gas are all related. Boyle's laws state that the pressure of a fixed mass of gas is inversely proportional to its volume if the temperature is kept constant. Charles's law states that the volume of a fixed mass of gas is directly proportional to its absolute temperature if the pressure is kept constant. Pressure law states that the pressure of a fixed mass of gas is directly proportional to its absolute temperature if the volume is kept constant. The combination of Boyle's law, Charles' law and pressure law develops into the universal gas law, that shows the relationship between the pressure, volume, and temperature of a gas. A change in one of these factors always produces a change in at least one of the other two, or even all three of the factors may change at once. Assume that the initial pressure, volume and absolute temperature of a gas are P1, V1 and T1, and its final values are changed to P2, V2 and T2. The universal gas equation can be written as shown. This equation is useful when the pressure, volume, and temperature of a gas all change simultaneously. Assuming one of the variables to be held at a constant value, we can look at the relationship between the other two for each case by using the following diagram. Cover the temperature that stay constant, you will get the relationship between pressure and volume. Cover the pressure that stay constant, you will get the relationship between volume and temperature. Cover the volume that stay constant, you will get the relationship between pressure and temperature.
How the combined gas law applies to everyday life. The combined gas law has practical application in our everyday life. It applies whenever the amount of gas remains constant, but pressure, volume, and temperature change. For example,
the title of my experiment is the crash can experiment. The needed materials are empty soda can, electric stove, boiling water, and the last is the tongs. First step, let the stove heat. Then put the can in the stove for 2 minutes. After 2 minutes and the temperature of the can increases, put the can in the water.
What happened? How? The rapid change in temperature inside the can causes the volume and the pressure decrease quickly.
Good day everyone, my name is Nasria B. Abdulmaki. So for today, I discuss about the other example of combined gas law. The other example of combined gas law is the moon. The moon has less temperature, that's why when a balloon is brought, that it will expand in volume. What about the temperature? Let's say that is the time when the moon forces the sun because it rotates every 27 days. The hot temperature contributes to the expanding of the balloon.
Hi guys, I am Bainaida Saidina. Today we were going to talk about combined gas law. So what is combined gas law? Combined gas law is a gas law that combines the Boyle's law, Charles' law, and Gay-Lussac's law in one equation, wherein the pressure is direct proportional to the temperature. So this gas law can be observed through the simple experiment called
Rising water experiment.
In order to understand the mechanism of the combined gas law, we will be doing a simple experiment at home. So in order to do this, let's start the experiment. For this experiment, we will be needing the following materials, which is glass, candle, lighter, and water with food coloring. So, before we start the experiment, we must always exercise caution. So, we will be needing a gloves. So, let's start the experiment. This is the result of this experiment.
How?
The candle light is blown out. The water level is inside the glass cup rises. Bubble come out of the glass cup. When we place the glass cup on top of the candle, the flame burns out since it consumes all the oxygen left in the glass cup. Also, the flame heats up the air, which expands and escapes the cup, causing the bubbles. Now, the cool air inside the cup contracts and the pressure becomes low while the pressure outside of the cup is high. The high pressure, atmospheric pressure outside the glass cup pushes in the water, which causes the water level inside the cup to rise. When we see how Charles' law is presented in this experiment, because as we said before, Charles' law explained that as a gas is heated up, it would expand, which explained the bubbles escaping the glass cup. And as a gas is cooled down, it would contract, which explained the rise of the water level inside the cup.
Hi, I'm May and Bernabe, and I will show you guys how works the combined gas law. The things we need to do or the things we need to prepare is the flask or the bottle. We then just small opening, then your egg and the boiled egg, the piece of paper, lighter, and also the hot water. This is the called egg in the bottle.
The only step for these experiments are to light your piece of paper with your lighter. Let it catch fire a little bit first so it's nice and hot. Drop into your bottle and place your egg over the top. To remove your egg from the bottle, and hold your bottle upside down over some boiling water with the egg covering the opening. As the air inside the bottle heats up, it's going to force the egg into the opening. Once it gets stuck into the opening, normally, when you place an egg on the top for the bottle, it won't fit through the bottle's opening because the egg's diameter is larger than the opening of the bottle. Since the pressure inside and outside of the bottle are the same, the only force that pushes the egg into the bottle is gravity, but the gravity isn't strong enough. Our bottle is full of air molecules. When we drop the flaming piece of paper into the bottle and seal the opening with the egg, the flaming water heats up the air molecule inside the bottle. When a gas like air is heated, the molecules move faster and try to spread further apart. But because the air is trapped inside the bottle, the volume of space that it can take is limited. Once the air has filled the volume of the bottle and cannot spread any further apart, the air molecules start to press against the wall of the bottle. And since the wall won't move, the air pressure inside the bottle increases rapidly as the pressure and temperature of the air inside the bottle increase. Some of the oxygen molecules are used in combustion, creating the products carbon monoxide, carbon dioxide, and water vapor. Once the pressure inside the bottle is strong enough, it will cause the egg just up and down and allow the air rush out into the environment. Both of these processes reduce the amount of air inside the bottle. But because the air is extremely hot, its volume still fills the bottle, and the high pressure remains. Once the majority of the air molecules have escaped the bottle or used in combustion, the flame of the paper will extinguish. Once this happens, the air inside the bottle will begin to cool, reducing the volume of the pressure but because we have far less air molecules inside the bottle than we started, the pressure inside the bottle dropped much lower than at the start of the experiment. Because of the pressure outside of bottle is higher than inside our bottle, the outside pressure exerted on our egg is strong enough to gently push the egg through the small opening and into the bottle. Once the egg is in the bottle, preventing air from entering the bottle is gone, and air rushes in, balancing the pressure inside and outside of the bottle. The opposite effect occurs when we remove the egg from the bottle. As we heat the air in the bottle, the pressure inside gets much higher than the pressure outside. The higher inside pressure generates a much stronger force than the pressure outside of the bottle, gently pushing the egg through the opening of the bottle until the egg shoots out of the opening, allowing the air to rush out, balancing the pressure inside and outside of the bottle. Well, that's it for the egg in a bottle. I hope you enjoyed.
It is also used in other thermodynamics and fluid mechanics calculations. Because the combined gas law is an ideal gas law, it only approximates